Hello there and welcome to the Hashpower Academy. My name is Jake Scanlon. I'm the lead educator here at the Academy, and this is a place to learn anything to do with Bitcoin and everything to do with Bitcoin, starting with the fundamentals. This is where we start with all the energy sector side of things, electricity converted in Bitcoin miners to produce hash rate, which produces Bitcoin blocks. And this brings us to the topic of the difficulty adjustment, the true test of your Bitcoin knowledge, the final exam, the litmus test in other places as they refer to it. And the difficulty adjustment represents the what I like to call dimensional axis, X, Y, and Z, where they meet in the middle. And those different components are what I like to call energy, space, and time. Those are the three key things to understand about the difficulty adjustment, even if it's a bit of a technical thing that you've not still wrapped your head around. At least understand the three key reasons why. We'll start with time. Time. The Bitcoin network wants to regulate the amount of blocks per day, at any period of time. It's trying to create a steady state of 144 blocks per day, and that is approximating 10 minutes per block. But on the network, you can have 20 blocks found in an hour, or you could have one block found in an hour. But the average across the entire pool of all the miners is reaching a steady state equilibrium at about 10 minutes per block. And the network, in terms of the code is looking back 2016 blocks. So if you do 2016 by 144, you get to 14, 2 weeks. So the network is constantly looking back at the amount of time it takes for blocks to be found over a 2-week period of what it thinks it's 2 weeks. 2 weeks as in 2016 blocks. And what is it observing? The amount of hash rate producing blocks. I hope you're with me still. And the three key reasons are, it's trying to regulate time to 144 blocks per day. Why? Because the steady state is that right now, the amount of Bitcoin being issued, the energy aspect, is 450 Bitcoin per day. 144 blocks in time per day, 450 Bitcoin in terms of energy issuance, digital energy per day. And space is, well, every block stores transaction information, ones and zeros, per day. Now, if 10% more hash rate come online, then it's not going to be 144. That's going to be plus 10% in terms of that relative period of time. That blocks are no longer going to be every 10 minutes. They're going to be approximating every 9 minutes. And it's the same with the amount of Bitcoin. That's going to be 400. That's going to be 10% more Bitcoin being issued per day relative to that period of time. And there's 10% more block space in terms of if there's more blocks, there's more Bitcoin being issued, more space for transactions, and well, blocks are going to be every 9 minutes. So energy, data space, and time. Now, they all sound like reasonable things. Oh, more time to, or quicker transaction settlement, more Bitcoin being issued, and more space for transactions to be stored, energy, space, and time. But those aren't good things, for the reason that, well, if this was 50%, then we'd be at 288 blocks per day, and it would be 900 Bitcoin per day. So the inflation rate would be double. And right now, the Bitcoin inflation rate annually is, it's approximating 0.78%, I believe, which is over half that of gold. Gold tries to average at 2% a year, and the inflation rate of Bitcoin is over half of that. So if the network was to double in this example, double in size, which isn't going to happen overnight, we don't think, and that's going to be 50% as well. Well, it would be, those blocks would be found in a week. At twice the amount of blocks per day, it would be 10 minutes per block, and twice as much Bitcoin, and the inflation rate in that relative time would double. And we don't want to increase the inflation of the scarce hard digital money. And it's the same with, there'd be twice as much block space. So what happens is the nodes storing all that data would be on an accelerated, without the difficulty adjustment, the nodes would have to have twice as much storage space, and they are volunteers. Nodes are volunteers. They are not being paid for what they do, and we don't want to impose more storage costs at a quicker rate than they already know what the rate of the Bitcoin network data size is growing at. We don't want to impose more cost on the volunteers that keep Bitcoin digitally decentralized. Now, on the issuance inflation side of things, we don't want to inflate Bitcoin at a higher rate. It's already got the lowest inflation rate across all of the different monetary assets, or monetary metals, shall we say. And yeah, we don't want to make blocks any less than 10 minutes because it's a synchronization issue. If a Bitcoin miner finds the block, he screams out to the network, "I found a block, here is my proof of work." He found the correct amount of zeros. And yeah, well, if it's every 5 minutes, there is more of a problem that not everyone's going to get out that information at the right amount. The synchronization issues, basically. And so the difficulty adjustment is constraining the amount of energy issuance, compute space that's available by constraining time. And so it's this invention of time. And why the difficulty adjustment has to constrain time is we're not using, the Bitcoin code doesn't just randomly pull an API and go, "Oh, hey, random website, what's the price?" Or even an atomic clock. The system is designed to not trust any one thing when it comes to decentralizing the issuance power, hash rate distributed to all the Bitcoin miners all around the planet. It's constraining energy, as in the amount of issuance of the money, and the block space. If we have small blocks and a constrained amount of pace between each block, if blocks are found faster, the fees on the fee rates will drop. But that fee rate keeps Bitcoin, the economics of using the fee market, competitive, for the reasons that its subsidy inevitably drops out into oblivion, to zero, and the amount of fees is going to become that natural market of buyers on the other side. And they are, in reference, paying for the security of multiple gigawatts, an entire country's worth of energy and compute, protecting their transaction integrity. And so the difficulty adjustment truly represents that point of energy, space, and time being regulated at the rate of energy issuance, data space, by time, and the pace of blocks being found, all constrained together. And it works by continually, every block that's found is timestamped. The amount of time between each block is timestamped. And so the issuance of who is submitting what the time is on the network is recorded, essentially. And so that gap of time between each block is measured over the previous 2 weeks approximately, or 2016 blocks. So if those 2016 blocks are found in quicker than 2 weeks, the network adjusts it to realign it back to every 10 minutes. So it's all this interplay of dimensions of energy, space, and time, but what it does is it constrains the money to not be issued too quickly. The storage space doesn't collapse the price of the fee market, which is the competitive side of consumption on the Bitcoin blockchain. And it all does it by regulating time. And essentially Bitcoin is a decentralized clock, because it's not pulling the time from one particular place. It's not trusting any one particular person. It's sourcing the time from all the different people that have captured their share of block rewards by finding a block and submitting time in the process. So it's yeah, it's quite a lot, and but it's fundamental. But it gets better. It gets a lot better. Oh. So when you circulate the system, the blockchain and the difficulty adjustment creates a time. The Bitcoin blocks being regulated in time, so that the pace of issuance and data storage, space and energy, are all constrained together. It forms pricing systems. So the conversion efficiency of Bitcoin miners, the data market of how much Bitcoin per storage space that you're paying for, and both of these two components create a new pricing system for Bitcoin against energy. And it's actually very circular. So we produce energy on electrical grids, consume it in homes and Bitcoin miners who convert that into hash rate, which export that energy onto the internet to produce hash power, which adds the Bitcoin blocks, which to this discussion, that constraint of energy, space and time ensures that the blockchain has the right amount of time between blocks, the right amount of issuance of Bitcoin, so it's not too fast, not too slow, and that competitive fee market aspect thing of storage space. We don't want to impose costs on the nodes. They are the volunteers of the network. We want as many nodes as possible, so I recommend you get some large multi-terabyte SSDs and save your own copy and version of the Bitcoin blockchain. And so yeah, Bitcoin creates this digital side of things of an energy, space and time sort of dimensional axis, and the Bitcoin code keeps the regulation of all of this, but it's not in one single place. Again, we're not trusting one single place. It's distributed and copied across every single person running their own node. And essentially, Bitcoin miners are energy nodes, Bitcoin wallets are economic nodes, and someone that has a full copy of the file, they are space nodes or something like that. And yeah, so I hope this was an interesting video. I'm going to do more sort of trying to break down the more technical side of things, but the difficulty adjustment is quite a nut to crack, as they say. I hope you enjoyed this video. Like, subscribe, share, drop anything in the comments. I'll probably do another difficulty adjustment video because, yes, continually seeking to improve. Kaizen, as they like to say. Goodbye.